Okay, so this next one is going to be about vector products, or what I call cross products, and what you might hear called cross products later. Vector product is more common within IB, but if you pursue math or physics in college, you might hear it called a cross product. So this first one, last or 2 classes ago, whatever it was, you learned about the scalar product or the dot product. So that took 2 vectors and returned a whole number. Instead, this one takes 2 vectors and returns a vector. It only works in 3 dimensions. These are the way the formulas look on your formula sheet. The first formula is for the cross product, and the second one is for the magnitude. So the vector product of 2 vectors is another vector that is perpendicular to them both. So if you have, considering the 3-dimensional plane, you have the X and the Y in one direction, and then the Z plane comes out perpendicular to both of them. Given 2 vectors, A and B, the vector product is given by this formula cross in the normal vector, where it's the unit vector. In physics, I think y'all learned about the right-hand rule, the right-hand screw rule, but basically you line up, it tells you the direction. You go, if it's A cross B, you move your hand from A to B, and your thumb should be pointing in the direction of the normal vector. If you need a demonstration of that in class at some point, that's fine, but I'm pretty sure y'all learned that during physics. As far as the properties of the cross product, again, they're pretty straightforward, but I think they're worth looking at just to make sure that you know what you're doing. The volume of a parallelepiped is here. It's an example of a mixed product. It's called a mixed product because it has both a cross product and a dot product in it. So 3 or more vectors are said to be coplanar, meaning they lie on the same plane. You can do a proof of that by using this volume of a parallelepiped formula and setting it equal to 0, because it would just be a flat parallelepiped, which would be one plane. Here, this formula, the volume of parallelepiped is on your formula sheet, I'm pretty sure. Let me double check real quick. Yeah, they call it an area of a parallelogram. So when you add just the 3rd dimension, that's how you get your parallelepiped. Yeah. Okay. So you do, if you want to memorize that formula as is, then you can. Otherwise, it's the formula for a parallelogram dot the 3rd dimension. Here, this one is definitely not on your formula sheet, but a triangular pyramid is 1/2 of a parallelepiped. I would assume that if IB were asking you these questions, they would give you these formulas, but that's not always a guarantee. So I think it's worthwhile to memorize them or to practice them, or at least know how they're related. Okay, so I didn't do as many example problems in this one because it's a lot of just plugging in numbers, which I think is pretty straightforward. So I didn't do many examples, but if you want to see some during class one of these days, you can ask. This worksheet is going to be up on Google Classroom as well.